Hello everyone. So welcome back to the good stuff that I've been doing. Today we're going to solve the 2025 MIT Integration B exam from MIT. So this is going to take us some time, although for this test you are required to do this under 20 minutes, I believe. So which basically means that you are required to spend nothing less than 1 minute per integral, and this is necessary because they are trying to get the best students to go for the main event, so they just want to use speed. Now, but that doesn't mean that the problems are something you can do under 1 minute. Of course, most of them you can, but some of them you cannot. So that is that. So for the first problem here, we are asked to integrate x plus square root of x divided by 1 plus square root of x. Now, notice that x, we can write x as square root of x times square root of x, of course. So in this case, this integral would become integral of square root of x times square root of x plus square root of x, and you divide by 1 plus square root of x. Now the reason for doing this is going to be clear as we factor here, and we're going to end up with you factor square root of x, you are going to have square root of x plus 1 all divided by, let's try this as square root of x plus 1. Okay, so dx. So basically this is equals to the integral of square root of x dx, which is just the integral of x to the power of half dx, which is x to the 3 halves over 3 halves plus c. So maybe we could write this as 2/3 x to the power of 3 halves plus c. So that is it. So you can see, of course, this one you can do it under 1 minute, but most of the problems you can't do under 1 minute. Now let's see for the next problem here. The problem 2 says we should do the integral of e to the x times e to the x plus 1 all divided by e to the x plus 1 dx. Of course, you can write this as the integral of e multiply e to the x all divided by e to the x plus 1 dx, and we can factor out e, and we write this as e times the integral of e to the x all divided by e to the x plus 1 dx. Of course, you can take u to be e to the x plus 1, where du would be e to the x dx. So in case this will be equals to e multiplied by integral of du over u, which is e times the logarithm of e to the x plus, sorry, the logarithm of u plus c. So, but we can write this as e logarithm of 1 plus e to the x. Of course, we don't need the absolute value because this is always going to be positive. So we can just write logarithm of 1 plus e to the x, then plus c. So that would be our final answer here. So the problem 3 here, number 3, I'll quote it. Let me see. Problem 3 says we should do the integral of the cube root of course, 3 sine x minus sine 3x. Now, you should be familiar that in this kind of problems, where you are required to do integral of maybe square root or integral of let's say cube root, you have to simplify the term inside the cube root or square root or whatever root that appears. Now we can simplify this, but you have to understand that sine 3x can be expressed in terms of powers of sine x. So there's a formula that says sine 3x does equal 3 sine x minus 4 sine cubed x. So in this case, then 3 sine x minus sine 3x would become 3 sine x minus 3 sine x minus 4 sine cubed x, and this would be equals to 3 sine x minus 3 sine x plus 4 sine cubed x, which is just 4 sine cubed x. So basically the integral of the cube root of 3 sine x minus sine 3x would be equals to, let's change color here. So this will be equal to the integral of the cube root of 4 sine cubed x, which is just 4 times the integral of sine x dx. I think this will be negative 4 cosine of x plus c. Okay, this is not 4, this is cube root of 4. Okay, so this is going to be the cube root of 4 times cosine of x plus c. So we're done with problem 3. Remains to do problem 4 now. Okay, that says the integral from 1 to e. Okay, of what? Of logarithm. We have a logarithm of x to the, let me write this below. The integral from 1 to e of the logarithm of x to the logarithm of x to the x, right? Okay. Okay, and you have to divide all these by x to the second power dx. Now we can simplify the logarithm because we know for one that the logarithm of x to the x is going to be x log x. So basically x to the power of logarithm of x to the x is just going to be x to the power of x log x. And I think we can write this as x to the power of log x to the power of x, which is just going to be okay, no, we can write this way. Wait, let me check. Let's just leave it like that and see. Okay, since we take logarithm, we just have, okay, let's just say we have the integral from 1 to e of the logarithm of, let's say we have x to the, then we have, let's use this fact, we have x log x. Yes, then all divided by x squared. So you remember that logarithm of a to the b is b log a. So we can have this as integral from 1 to e of x log x times what? Times logarithm of x, and then divide by x squared dx. Dx, yeah, of course. So this would be integral from 1 to e of, the x is cancelled out. You have log x squared all divided by x dx, and of course instantly we must take u to be log x. So you must take u to be log x. So in this case, du would be 1 over x dx. So if u is log x, if x is 1, u would be 0, and if x is e, u will be 1. So we're taking this to equal the integral from 0 to 1 of u square du, which is u to the third power over 3. We are evaluating this from 0 to 1, and that would be just 1/3. So of course the value of this integral would be equal to 1 over 3. So now that is done. So let's go to problem 4 here. Okay, this is problem 4. Okay, let's go to problem 5. Problem 5 is all about this function here from negative pi over 2 up to pi over 2 of what? Of cosine of 20x, and then sine of 25x dx. Now, whenever you are given any integral and the limit of integration is a symmetric interval, let's say from negative a to a, you should remember that the integral from negative a to a, that's over a symmetric interval of f of x dx equals 0. So if f of x is odd function, so odd function. Now we have to check if this is odd function. Let's set f of x to be cosine of 20x, sine of 25x. So let's say f of negative x is cosine of negative 20x, sine of negative 25x, which is going to be cosine of 20x, and then sine a negative, that is negative sine of 25x, which is going to be negative cosine of 20x, and then sine of 25x, which is negative f of x. So basically, f of negative x is negative f of x. So this function is odd. So since it's an odd function, we don't even have to suffer ourselves. This integral equals to 0. And here, keep in mind that we use the fact that the cosine of negative x is basically cosine of x, because cosine is an even function, but the sine of negative x is negative sine of x. That is why in this case here, there was no negative here, but there was a negative here, because sine is odd function. So keep that in mind. Now let's proceed and see what we can do next here. So let's say the problem 6 here. The sixth problem is integral from 0 to 2 pi, and you have a very long expression. So you have sine x, you have cosine of x, and you have, let me put them in brackets so we don't confuse things. Sine of x, cosine of x, then you have tan of x. All the three functions are here to party. So cotangent of x, everybody is here to party. And then secant of x, and then cosecant of x. Yes, of course, you don't even have to ask yourself what is your approach. It's straightforward. The approach is to convert everything to the normal form. So let's say we have sine of x, we have cosine of x, then this will be times in sine of x, cosine of x, and then cotangent is just cosine of x over sine of x. Then secant, this will be 1 over cosine of x times 1 over cosecant is 1 over sine of x dx. So this will be, of course, these two, they cancel out. No, sorry, like this here, sine cancel sine, cosine cancel cosine. Then we have 0 to 2 pi of sine of x, cosine of x. On the bottom, you still have cosine of x, then you have sine of x dx. So this will be just the integral from 0 to 2 pi of 1 dx, which is just 2 pi minus 0, which is basically 2 pi. So the answer to this is going to be 2 pi. Okay, that is that. Easy. Now, you can see why this problem is put 1 minute per integral. Of course, if you are a student taking this, doing this exam, I'm sure that you already know before that all of this will simplify to 1. So you probably will skip all of this step and just write 2 pi as your answer. So you can see that you can even do this even in less than 5 seconds. So you now have some 40 seconds to save on the next problem. So of course, this exam is to select the very best student. And I think the very best students already must have seen this problem before and gotten the solution. So we can still continue and do number 7 here. So 7 says if we do the integral of x, then you have log x. So let's put it x log x, and then you have cosine of x minus sine of x, all divided by let's say x log x, or x log x squared. So x log x all squared. Now this integral now looks extremely complicated to even look at. But if you split it into 2 parts, this is going to give you the integral of cosine of x all divided by log x. And then you are going to have minus, you would have sine x all divided by x log x squared. So all divided by x times log x all squared dx. Now you should observe that this, try to take derivative of sine of x all divided by logarithm of x. The reason is that, notice that at the very top, you have cosine of x, showing you that probably somewhere at the top, we took derivative of sine. Because if you take derivative of uv, like d du, if you take d dx of, let's say, u over v, you would have v squared at the bottom, and at the very top, you will have the derivative of u multiplied by v minus derivative of v multiplied by u. So in this case now, this d dx of our sine of x divided by logarithm of x, this alone would equal the derivative of, we're going to get log x squared, so logarithm of x squared. Of course, that is where this log x squared came from. Then at the top, we're going to have to differentiate cos x to multiply by log x squared. So we're going to have cosine of x multiplied by the logarithm of x squared. Then at the bottom, then we're going to subtract this by derivative of log x is going to be derivative of log x is going to be 1 over x, of course. So you're going to have 1 over x. Then you're going to multiply by sine of x. And then when you multiply all through by x, you will have x cosine of x times what? Times logarithm of x all squared minus sine x all divided by logarithm of x all divided by x logarithm of x all squared. So give me a minute, let me get water. All right, so you can see that this matches with the pattern we have here, and we can just say this is the sine of x all divided by log x plus c. Now you may be asking, okay, how am I supposed to spot the pattern in a very short time, like 1 minute? Well, students who prepare for these exams, they already memorize a whole lot of patterns, and one of them is to recognize the derivative of a quotient. Sometimes the integral is not a straightforward substitute, partial fraction. No, sometimes you need to really suffer to actually get the answer. And sometimes there are shortcuts to this, and the shortcuts involve you knowing when to recognize this pattern. This is one of those cases. So let's do sorry about that. Let's do problem 8 now. So that is the integral. Problem 8 is the integral from, okay, not a different, from 1 to 2, yes, 1 to 2 of what? Then you have 2 to the x minus 1, then you have plus logarithm to base 2 of 2x. Understand that this is logarithm to base 2, not base e. Okay, of 2x, then dx. Of course, we have to split this into two integrals. There's no way we're combining these to suffer. So we're going to do the integral from 1 to 2 of what? 2 to the x minus 1 dx. Then next up, we're going to do the integral from 1 to 2 of logarithm to base 2 of 2x dx. And this would be equal to 1 over 2 times the integral from 1 to 2 or 2 to the x dx, obviously. Then this would be equal. Now notice that we can do change of base here. So because we know that logarithm of a to base b is logarithm of a to base c divided by logarithm of b to base c. So we can change the base from base 2 to base or we can even factor. We can write it as 1 to base 2, 1 to 2 of, let's just say logarithm to base 2 of 2 plus the integral from 1 to 2 of, let's say, just logarithm to base 2 of x, logarithm to base logarithm of base 2 of x, yes, dx. Of course, this dx here. Now with this pattern, we can continue and probably write this as, here it's clear that the integral of a to the x is just going to be a to the x over log a. So this is clear. So this is going to be half of 2 to the x over log 2. And then, not log 2, rather, yes, log 2, yes, log 2. So it's going to be 2 to the x over log 2. So just write log 2. Then plus here, this will be just log 2 minus log 1. So that is just going to be log 2. So it's just going to be log 2 minus log 1. So this is going to be just log 2. Then this is going to be plus. We're going to convert log 2 to log. So this is going to be 1 to 2 of logarithm of x divided by log 2 dx. So we're going to have half of logarithm of 2 to base e. Yes. So we're going to get half of 2 to the x over log 2. Then plus, you're going to have log 2 only. Then plus, then you're going to have 1 over logarithm of 2. So integral from 1 to 2 of logarithm of x dx. And if you know the theory of integration, you should know that the integral of log x is basically x log x minus x. So if you take this from 2 to 1, you would have 2 log 2 minus 2. So you have 2 log 2 minus 2. Then if you take from 1, you have 0. So you have 1 log 1 is 0 minus 1. So you have subtract 1. So you are going to add 1. So you have add 1. So that is 2 log 2 minus 1. I believe so. Let me check. Okay, so that would be giving you half. Okay, this is actually a definite integral. So we're going to do this from 1 to 2, and we're going to do this from 1 to 2. So this from 2, you will have 2 squared. So that would be half 4. So that is 2 over log 2 minus from 1, you will have log 2 minus 1 over log 2. Okay, so that will be just 1 over log 2. So we'll just write this as 1 over log 2. 1 over logarithm of 2. Then this would be plus logarithm of 2. And then this will be half of logarithm of 2. Then you would have 2 logarithm of 2 minus 1. So let's see if we are correct. Okay, this is 1 over log 2. Okay, plus log 2. Then you have plus, then this will be 2 plus 2. Then this will be minus 1 over log 2. Okay, so this cancel out. Okay, so what is remaining? Two plus log 2. I think there must have been a mistake somewhere, but I'll check. Okay, I think my mistake here is the part where I did log 2 to base 2. Log 2 to base 2 is basically, this is base 2. This is going to be in base 2, and this is going to be in base 2. Okay, so base 2. So this is going to be just equals to 1 plus 2, and this is going to be 3. So yeah, now we have our final answer to be 3. Okay, now let's move on. We're going to look at number 9. Okay, this is a very interesting integral also. Number 9 says we should do the integral from 0 to 1 of what? So you have here x to the 2024, okay, and then you multiply this by 1 minus x to the 2025 dx. All right, so how are we going to deal with this one here? Let's make some substitutions here. For the substitution we're going to make here, we're going to start with just taking x to be 1 minus, no, taking u rather. We're going dx. So this is we're going to take u to be 1 minus x to the 2025. So du will be negative 2025 x to the 2024. So basically dx. So basically x to the 2024 dx is going to be negative du over 2025. And if we take this substitution, notice that when x is 0, u is 1, and when x is 1, u is 0. So you're going to take this as integral from 1 to 0 of negative du over 2025 times u. Okay, so that would be 1 over 2025. So we'll write this as 1 over 2025 times integral from 0 to 1 of u du. Okay, okay. Hope I'm still within the range. Okay. All right. So, okay. Sorry, this is also raised to a power. Let me see. Sorry about that. This integral we can just do it as it is. So just 1 over 2025 times u squared over 2 from 0 to 1, which is just 1 over 2 times 2025. But the original integral from the book actually has an extra factor of 2025 here. So this is raised to the power of 2025. So what this is supposed to mean is that this is going to be not this anymore. It's going to be u to the power of 2025. So rather, it's going to be integral from 0 to 1. That is 1 over 2025 multiplied by u to the power of 2025 du. So which is going to be 1 over 2025 times 1 over 2026. So this is going to be 1 over 2025 times 2026. And of course, if you are familiar with beta integral, we know that this integral, which is integral from 0 to 1 of x to the 2024 times 1 minus x to the 2025 and then u to the then 2025 once more. This integral dx here, there's another way we can do it. If you remember that the beta integral, beta of x comma y, is the integral from 0 to 1 of what? T to the x minus 1, then you have 1 minus t to the y. The beta integral, it's t to the x minus y times y minus 1 as well. So this is the t. So this is the beta integral. Now you can compare here, except that in this case here now, we don't have a factor here. Like here, t does not raise to any power. So the best way is to just put t to be this. So you just put t to be x to the 2025. If you do that, you will have dt to be 2025 x to the 2024 dx. So in this case, if you compare both sides, what you would have is that, notice that if they will have the same limit, so you have the integral from 0 to 1. Now this x to 2024 dx is going to be dt. So you have 1 minus t dt. We can write this as t to the power of 0, 1 minus t dt. So this will be the beta of 0. Sorry, there is a factor of 2025 here. Of course. So this will be the beta of this will, no, not yet. Oh, this is not yet beta of something. We're going to write this as in terms of t minus 1. So this is going to be the integral of t to the 1 minus 1, 1 minus t to the 2025 dt. So this is going to be beta of what? 1, then 2026. And we can relate this to the gamma function. Of course, this is gamma of 1 times gamma of 2026 all divided by gamma of 2027, right? Because 1 plus 2026 is 27. So this can be equals to just 2025 factorial all divided by what? All divided by 2006. No. Yes, all divided by 2026. So this will be just factorial. This will be just 1 over 2026. And of course, I forgot the extra factor because this dx is 1 over 2025. I'm supposed to have 1 over 2025 here. So this whole of this is multiplied by 1 over 2025, 1 over 2025, and 1 over 2025 here. So basically, everything is the same answer as before. So no need to waste too much time on that now. Let's move on. Okay, now we have to do number 10. Number 10 here says that we should do the integral from 0 to 10 of, we have some nice expression here, x minus half, and then x minus 1. Now here, don't be too fancy. Of course, you have other ideas like trying to like factor something or do some weird stuff, but you can't do anything here. You just have to multiply. This will be the integral from 0 to 10, obviously, of x first, of x squared minus x. You're going to multiply this by x minus half dx. So you're going to get 0 to 10. First of all, x to the third minus x squared over 2 minus x to the second power plus x over 2. Okay, so this will be x to the 4 over 4 minus x to the third over 6 minus x to the third over 3 plus x to the second over 4 power. No, x to the, yes, there is that. So we are going to evaluate this from 0 to 10. For the part, everything vanishes. From the 10 parts, we are going to just have this is 10 to the 4 over 4 minus 10 to the third over 6 minus 10 to the third over 3 plus 10 to the second power over 4. Now we can use calculator to do something here. We're going to get everything here to equal 2025. Okay, so everything 2025. So that is the answer to that. Now we have something interesting on our sleeve. Now we have problem 11. Problem 11 says we should do the integral from 0 to 20 of what? Of the ceiling of the floor of x over 2. So the ceiling of the floor of x over 2 dx. Now let's first of all consider the inner function. Let's say the ceiling of the floor of x over 2. Now notice that so long as x is between n and n plus 1, it is definitely clear to us that this expression here, the floor of x, would definitely be equal to x itself. So long as x is between n to n plus 1. So the ceiling of the floor of x, the ceiling of the floor of x over 2 would become the ceiling of n over 2. Will become the ceiling of n over 2 if we simplify this. So what we're going to do is that we're going to split this. This is from 0 to 20. So this we're going to split this integral from 0 to 1 of the floor of 0 to 1 of the floor of the ceiling of floor of x over 2 dx. Then we're going to add this from 1 to 2 of the ceiling of the floor of x over 2 dx, and we're going to continue up until we get to 19. So we get from 18 to 19 of the ceiling of the floor of x over 2. And of course we can't include 20, because in this case the ceiling will be zeros as well, so we just stop at 19 there. So basically this is going to be equals to the sum as n equals to 0 to 19 of the integral of n to n plus 1 of what, of the ceiling of n over 2. Like, notice that in each of this interval the floor of x will be x. Okay, the floor of x will be x. So in this case now, this would be equal to, we can factor out the ceiling. So this will be equals to the sum as n equals to 0 to infinity of the ceiling of n over 2 times the integral of n to n plus 1, this is dx, that is dx. So this will be the sum as n equals to 0 to infinity, sorry, not infinity, rather 19 19. So this will be the ceiling of n over 2, and then times what, n plus 1 at the top minus n at the bottom. Okay, so this is just going to be us. At here we're going to just have to compute the ceiling, the sum of, as n runs from 1 to 19, of the ceiling of n over 2. As if we compute this, we're going to get our final answer. Now if you sum this, of course, in the first interval you will get the, oh sorry, n is running from 0. You will get, first of all, the ceiling of 0 over 2, then plus the ceiling of 1 over 2, plus the ceiling of 2 over 2, then plus the ceiling of 3 over 2, and then plus up onto the ceiling of 19 over 2. Now in this will be 0, obviously. The biggest integer here is going to be 1. It's going to be 1 up until we get to where? Up until we get to this, it's going to be 1. So it's going to be 1 plus 1, then you have 2. Then it's going to be 2 until the next term, so you have 3 plus 3. So the pattern is going to continue this way. Then we're going to get 9 plus 9, then we're going to get 10, 2. So if we sum all of this with a calculator, we're going to get, okay, we can even factor 2 in all of this. Can we? Okay, 1 appears 2 times, so 1 appears 2 times, 2 appears 2 times, and 3 appears 2 times. Also 4 appears 2 times, so everything will appear twice, and 9 will also appear 2 times, then remaining 10. So in this case 2, you have to just calculate 1 plus 2 plus 3 plus up until 9, then you have to add to 10. Now if you use the summation formula, we know that the sum of as k runs from 1, the sum of k as k runs from 1 to n is n plus 1 over 2. So you will have this to be 9 times 10 all divided by 2 plus 10. So you have the 2 cancel out. 9 times 10 is 90. So you have 90 plus 10. So you would have 100. So the sum here would have to be 100. Okay, so that is that. So final answer is 100. Now for number, let's look at the last problem, the number problem 12. Okay, last problem. This is 20 problem. So let's look at problem 12 here. Oh, this is integral form, not definite integral, but it has a weird root. So 3 over 1 root on the outside. Then on the inside you have x, then you have 4 over 2 roots, and then in the inside you have x, then you have 5 over 3 roots. The inside you have an x, and then you have 6 over 4 roots, and then inside you have an x, and it continues this way, and you have to find this integral dx. Now, of course, you will know that this is definitely going to be equals to the integral of x to the power of s, where s would be the form of these square roots, like or no, I mean these roots, whatever form they would be, or we just write it as n, whatever dx. So we need to find the value of n. Is n equals to 7? Is it equals to 12? Is it equals to x squared? How do we, if we can find the value of n in this case, then of course we are in good hands. Now, how do we deal with that? In each case here, the first, we can write this as the first root term I1 is 3 over 1. We can let us write this as 2 plus 1 over 1. The second one here is 4 over 2, and let's just write it as 2 plus 2 over 2. The third root term here is 5 over 3, and let's just write it as 3 plus 2 over 3, and continuously we see the general pattern here. So basically the ith root here, so in this case this integral will be equals to x times x times x times x, then times up until you can see the 1 over I sub the fourth one, 1 over the I sub 3, or 1 over I sub 2, and then 1 over I sub 1. So if we collect, you will have x to the 1 over I sub 1, then times you would have x to the 1 over I sub 2, then you will have times x to the 1 over I sub 3 up until continuously, then all raised to the power of what? 1 over I sub 1 here. So this would then be equals to x to the 1 over I sub 1 times x to the 1 over, you have I sub 1, I sub 2, x to the power 1 over I sub 1, I sub 2, I sub 3, and continuously this way. This will be x to the power of 1 over, it will be I sub 1, I sub 2, I sub 3, I sub 4, and then continuously and so on. So this would be, the general pattern here will be x will raise to the sum as k runs from 1 to infinity of the product of 1 over the I sub I. So the product of, as j runs from 1 to infinity as well, of what? I sub j's. Now let's first find the product here. Let's take p to be the product of of j. J runs from 1 to infinity of I sub j. So notice that in this case we are looking at the product of as j runs from 1 to infinity of what? J plus 2 over j. Look, using the pattern we already devised. So this would be equal to 1 plus 2 over 1 plus times 2 plus 2 over 2 times, then you will have 3 plus 2 over 2, and then so on. So you will have up until k minus 1 plus 2 over k minus 1 times k plus 2 over k. So we'll get a lot of cancellation. So the product p would be equals to k plus 1. It's not infinite, it's p sub k. The k product is not infinite. The k product will be as k plus 1, k plus 2, all divided by 2. Okay. Now here notice that this case now okay, so this case now x now, so x then notice that we need 1 over this. Okay, sorry. We need 1 over this, yes. Because x, remember that, recall that x equals 1 over the product. X is raised to the power of 1 over p sub k. So this case, x is raised to the power of, let's first find 1 over p sub k first. So in this case, let's first find 1 over p sub k. So 1 over p sub k is going to be the sum as k runs from 1 to infinity of 1 over k plus 1, k plus 2, and all divided by 2, which is going to be twice of the sum as k runs from 1 to infinity of 1 over k plus 1 and then k plus 2. Now this sum, you can use a partial fraction to break it down. You probably get 2 divided by the k equals to 1 to infinity of 1 over k plus 1 minus 2 over minus 1 over k plus 2. And if you sum, they are going to telescope, and you're going to end up with 1. You're going to end up with 1 as a final answer. So basically, you have x to the power of 1 over p sub k is x to the 1. So in which case here, n here equals to 1. So this, our integral is x dx, which is x squared over 2. So that is that. Thank you for watching. And now let's move to number 13. We are required to find the integral from just of e to the 2x times what? Times x squared plus x, all divided by x e to the x to the 4th power plus 1 dx. Now this setup here, let's simplify the bottom expression here. Like let's say you take u to be x e to the x. Rather than instead of this, let's square. We have this will be x squared e to the 2x. The reason for this is because this expression at the top here looks like something at the bottom. Like for example, now if you take u instead to be, let's say, x e to the x, so let's take derivative. Then derivative u prime would be first of all, you have e to the x, then the derivative of, then you have plus what? Plus x e to the x, yes, plus x e to the x. So if you factor, you have e to the x, then you have plus x. But then here we have an x squared plus x. So imagine that we take just u equals to, now let's say x e to the x, but let's say we square it. This would then be x squared e to the 2x, like here. Then the derivative here, u prime, would be, first of all, the first one would be 2x e to the 2x, then plus 2x squared e to the 2x. So you can factor this as 2 e to the 2x. You will have x plus x squared. So you can see that if we take this both step, you would have what we have at the top here, except for extra factor of 2. So in this case, if we take u to be this, then this means that e to the 2x x squared plus x dx would be du over 2. And that helps us to simplify a lot of things, because in this case, you have 1 over 2 times d all divided by u squared plus 1, and this is half of arctan of u plus c, which is half of let's see, so that will be half of arctan of x e to the x plus what? Plus. So that is that. That should be our final answer. Now let's look at problem 14 here. So problem 14, we are required to find the integral of secant to the 4th power of x minus what? Tan to the 4th power of x, okay, dx. And this integral quite maybe a bit tricky, but we can use difference of squares for it, because if you notice here that let's say we can write this as secant squared x minus all squared minus tan squared x all squared. So we can have secant squared x minus tan squared x, and you multiply by secant squared x plus tan squared x. Now notice that because we know that tan squared 1 plus tan squared x is secant squared x, means that 1 would be equals to secant squared x minus tan squared x. So basically this will just be secant squared x plus tan squared x. So we can write this integral. So for this I here would be equal to the integral of secant squared x plus tan squared x dx. Now what can we do here? Secant squared x, we can derivative of tan x is secant squared x, so we can write this as the integral of secant squared x separately plus the integral of tan squared x dx separately. So the first one is just tan of x, because the derivative of tan x is secant squared x, plus the second one is going to be the derivative of, we can write tan squared x as secant squared x minus 1 dx. So you can see this is going to be tan of x plus, now you have tan of x minus x. So that should be going to be 2 tan x. So 2 tan of x minus x, then you have plus c. So that is that for problem 14. Now let's look at problem 15 here. So 15 is somehow a bit challenging for us. Let's see. So for 15 here, we need to do the integral from 0 to 1 of x times, so the integral okay, so this is the integral from 0 to 1 of, you have square root of x, then you have 1 minus x. Now there's a neat way to do this. So one common way you can try to do something like this is probably to take x to be sine squared x. You can take x to be like sine squared x, and you have 1 minus x squared to be 1 minus cosine squared x, and something can happen here, but you can notice, just set y to be square root of x and then x minus 1, and notice something here, that y squared will be x squared minus x. Okay, so in this case now, that means you can complete the square here. You can have y squared will be, let's say, x minus half all squared, so x squared minus x, then you have plus 1 over 2 squared. So that means y squared how do I even put this one? Y squared is okay. Let me just put it in this form. Okay, no, I think we can complete the square here. According to the equation of a circle, but you won't get, okay, you won't get a circle, you will get an ellipse. Okay, so okay, no, I did it wrong. Let me take this out. I did it wrong, sorry about that. So because you have y to be square root of, let's say, x, 1 minus x, okay? And then y squared would be x 1 minus x. So basically, y squared minus x plus x squared would be 0. So which means that y squared plus x minus half of squared minus 1 over 2 squared is 0. Which means that y squared plus x minus half squared equals over 2 squared. So this is now from 0 to 1. So you're talking about the area of half a circle with the radius equals to half. So basically the area is pi r squared. Half of it is going to be half of pi r squared, which is going to be half of pi times 1/4. So we're going to get pi over 8 as our answer. Now, if you try to do this with the substitution of x equals to sine of theta, you will definitely get 1 over 8, pi over 8 as your answer. So try that one out yourself. Now, let's see number 16. So we have to deal with the integral of sine of 4x multiplied by cosine of x, all divided by what? All divided by cosine of 2x times what? Times sine of x. Now, sine of 4x, this is the integral of 2 sine of 2x cosine of 2x. And then you also have cosine of x. So you have cosine of x here. Then at the bottom, you now have cosine of 2x here times what? Sine of x dx. So we can even simplify, can cancel cosine of 2x, so you end up with the integral of 2 sine of 2x cosine of x all divided by sine of x dx. I think we can even do something. We can write this as the integral of 2 times 2 sine of x cosine of x times cosine of x all divided by sine of x dx. So over here to the right, you can see that the sine of x cancel out, so you end up with 4 times the integral of cosine squared x dx. Now cosine squared x, this is going to be 4 times the integral of 1 plus cosine of 2x all divided by 2 dx. So this would definitely be equal to, we can cancel out the 2's, so we have the integral of 2 plus 2 cosine of 2x then dx. So this will be 2x plus 2. Now this will be sine of 2x over 2, so that will be sine of 2x plus c. So that would be 2x, this will be 2x plus 2, sorry, plus sine of 2x. Yes, so that would be our final answer for there. Now let's look at problem 17 here. Okay, problem 17 says we need to find the integral of sine x times what? Sine, the hyperbolic sine inverse. So sine hx, okay, dx. Now we can use integration by parts, which says that integral of u dv is equals to uv minus the integral of v du. Okay, so in this case, the integral of sine of x times hyperbolic sine of x, okay, dx would be, first of all, you will have sine of x cos x. Now we are going to subtract derivative derivative of sine x is cosine of x. So we're going to subtract the integral of cosine of x. Then you have cos x. And then we can repeat it again. The integral of cosine of x, then cos x dx. Of course, this will become the integral of cosine of x times sine x minus the integral of plus the integral of sine of x times sine hx. So this will be so you will have the equation that I is equals to, because if you consider something here that this is taking you as your I, so you have the equation that I is equals to sine of x. So you have sine of x times cos of x minus, then you have cosine of x sine of x, then minus I again. So basically 2i would be equals to sine of x times cos x minus cosine of x times sine x. So the resulting integral will be dividing this by 2. Of course, you have to add your plus c. Okay. So now let's do number 18. So we're almost there. So number 18 says that we should do the integral. This is the definite integral from 0 to pi over 3 of what? You have sine x, and then you have cosine of pi over 3 minus x. Now we're going to do use a trick. Minus x. Let me write this well. So you have cosine of pi over 3 minus x dx. So we're going to use a trick, and which is that the integral from a to b of, the integral from 0 to a of f of x would equal the integral from 0 to a of f of a minus x. So we're going to take, in this case now, we're going to, this integral would be equal to the integral from 0 to pi over 3. But this integral would equal the integral from 0 to pi over 3. Then you have sine pi over 3 minus x. Then you have cosine of if we put pi over 3 minus x here, you will see have just cosine of x dx. And then if you can transform it and see, like if you add the two integrals together, because they are going to be equal, so this is going to be I again. So if you add the two integrals together, you have 2i would be equal to, now you have the integral from 0 to pi over 3 of what? You have sine x, so you have sine x times cosine of pi over 3 minus x. Then you have plus cosine of x times the sine of what? Pi over 3 minus x. Now if you remember that our addition formulas for sine of a plus b, sine of a plus b is going to be sine cos a, so you're going to be sine a cosine of b. Then you would have plus sine b cosine of a. So if you have this sine of pi over 3, if you put in what expression can we make here? If you take a to be x and b to be pi over 3 minus x, So you have a plus b. A plus b is going to be x plus pi over 3 minus x. So you have s pi over 3 minus x. So which is going to be pi over 3. So in this case, this 2I, or rather I, is going to be half of the integral from 0 to pi over 3 of sine of what? Of sine of pi over 3 dx. And that is just 1 over 3 times pi over 3 times sine of pi over 3. I think sine of pi over 3 should be like square root of 3 over 2, which is going to be pi square root of 3 all divided by 3 times 2, all divided by 12. So you have pi square root of 3 over 12 is going to be our final answer in this case now. Now that is that. So let's look at number 19. So problem 19. So let's stop here. And we're going to continue next time.